Good morning and hello to everyone. Please feel warmly welcomed in our booth at the FME World Fair 2021. My name is Christoph Dittmann, and in this short presentation, I would like to show you how we accelerate our FTTH rollout with the help of FME. Looking at the ranking of European countries prepared by the FTTH Council Europe, we do see that Germany ranks quite low on this graph, even below the EU average. With this situation, we can't be satisfied at Telecom, and in fact, we aren't. Therefore, we have decided to invest heavily into our optical fiber infrastructure and to connect up to 2 million households per year from this year onwards. This ambitious target, however, implies also that we need to rethink and redesign our way of working. Big emphasis needs to be put on standardization and automation of as many working steps as required. While thinking about redesigning and rethinking our way of working, we must not forget that some cornerstones need to be taken into account as well. So we need to provide a performant planning environment with an easy access to data. We shall be able to serve multiple use cases. We need to be able to deliver ready-to-use products. Customized applications and workflows shall also be provided. And last but not least, all of this shall be intuitive and user-friendly. Otherwise, we won't have any uptake by our end users. After some sessions of design camps and end-user consultations, there was only one option left on the table. And this was basically setting up a spatial data infrastructure on performant cloud computing environment. Here, we have decided to deploy the SDI on the Open Telecom Cloud, the OTC. Our SDI consists of several independent components. So we do have here the PostGIS database to store all our spatial and non-spatial data. We do have geoprocessing tools or capabilities within Actinia, which is basically the GRASS GIS for servers. We do have also a network for our metadata to make our spatial data discoverable. GeoServer is being used to serve and publish our data via web mapping services. The Shogun WebGIS is a WebGIS client that can be easily customized and adapted according to the requirements by the various use cases or as the end users do require them. The OSM importer allows us to store and provide the OSM data and services within our SDI. The 3D viewer or fiber 3D viewer is a 3D or better 2.5D viewer to allow the end users to interact in a semi-3D environment. We do have also some AI and machine learning tools integrated in our SDI too. FME is in the center of this SDI, not only this picture here. It is in the center because it does plays here a central role. FME does not only take up the, I would say, traditional tasks of FME to import data, transform it into various formats, maybe run some QC, QA tasks. But in our case, FME control and coordinates all the workflows that are needed for the specific use cases we need to satisfy. So actually, FME is a kind of a broker or facilitator between these components of our SDI and make sure that all the workflows are carried out in a proper manner. As I have mentioned before, our solution should be able to serve multiple use cases. And with this architecture, actually, we see ourselves in a good position to, on the one hand, stay flexible and adapt to those new use cases or develop the solutions for new use cases, but also we are in a good position to change the existing ones, provided there would be any requirement for this. As an example of such use case is the automated surface discrimination for the provision of routing for cost-optimized trenching. The costs of civil engineering depends highly on the surface type which is going to be dug up. Therefore, LiDAR data, photographs are being collected by the means of the T-surface car in the project area. With the help of artificial intelligence, the surface is classified, and for each class, the cost label is being attached to it. The areas that the surface car couldn't cover are then complemented by airborne data. Those two sources are combined together in order to provide what we call the potential trenches. These potential trenches are then supplied to our colleagues at the regional offices. They combine these data sets with the existing infrastructure over there and calculate the new network design for fiber network. And at the end, this is also used for documenting purposes and for communication with municipal authorities in order to obtain their approval for the civil works in the streets. Our colleagues in the regional offices are provided with a web interface, which we call the Fiber Manager. Within this Fiber Manager, he can initiate the process of potential trenches provisioning. However, behind the scenes, there are many FME jobs are being triggered. FME Server Automations came quite handy here, as they are event-driven and serve our purpose perfectly. Some of them are triggered by arrival of new data. Let's say new point clouds are being uploaded to the SDI, or new photographs or whatever. Other automations are triggered by registering new project area within this Fiber Manager. So we do use mainly here the directory watcher as a trigger. And in case of registering new project areas, we use the WebSocket messages trigger. On this slide, we do see only a small subset of automations running on our server. However, we do have a quite bunch of them. And one could say that we follow here the philosophy of microservices. As in our case, we can do the changes to one of the automation and will not interfere or destroy another ones. So they are quite independent. Another example of a use case where FME jobs are running behind the scene is the switch cabinet placement. Here we see a synchronized map and 2.5D view for planning purposes. On the left-hand side, we do see the classified surface types and objects with a viewing cone of a camera. On the right-hand side, we do see the situation as it is seen by the camera itself. In this photograph, we do see the car and the person blurred, and this is taken by FME behind the scenes. So basically, when we've got such an imagery, FME triggers a picture anonymizer, and within this anonymizer, the picture is then, within the picture, the objects are detected and blurred accordingly. We do also have here the possibility to place the cabinet, as the use case name says, and have also some possibilities to provide measurements on the street and so on. So with this application, we basically minimize the necessity of our colleagues to go into the field and to make this measurements and assessment in the field itself. And hence, with this, we basically accelerate the planning process quite much, and everything can be done from the desktop in the office. This tool is also planned to be used as a communication tool with authorities, where the placement of the cabinets need to be approved as well. With those two examples of our use cases, I admit the most fancy ones, I just wanted to show that we have a set of workspaces developed and deployed on our SDI, and we came soon to this point where we realized that we need kind of version control and adapt some clean code practices. Since managing or controlling the workspaces within GitLab, as our developers used to do with their Python or Java codes, it's not easy yet. So we came up with a solution which we called version template logger. This template version logger is part of every workspace deployed within the SDI. It logs automatically every change of the workspace and writes it into a database table. This helps us to maintain the overview on changes and provides kind of versioning control. In case it is needed, an easy rollback is also possible. I need to mention here as well that we have this situation 4 times, as we do have 4 environments. We do have, of course, our production environment, but we do have also development, integration environments where all the tests are being carried out, staging environment as well, and as I mentioned, the production environment. So such a clean code practice or this version logger template helps us quite a lot to basically keep track on all of these changes, and in case some problems occur, this can be relatively easily tracked back and then corrected. So to conclude, I must say that FME proves one more time to be the Swiss Army knife for data juggling, but not only data, it is also perfectly suited for workflow management too. At least but not last, I would like to acknowledge our partners for their support in this fantastic adventure. Actually, it wouldn't be so much fun without our friends. Therefore, here are the lollipops for all of our partners. Thank you very much for your attention, and I'm happy to take any questions if you have them. Thank you. Bye.